Okay, so I am going to record them and post them. So if you prefer to watch at your leisure, you can do that, or you can show up for the live lectures. That's fine. Okay, let's take a look at, to start with, let's look at our course outline. So this should be 2022, of course. I always have at least one typo. So this is an introduction to object-oriented software development in C++. All right, so we'll get into a little bit of what are the goals in this course, what you should be learning, and why we're using C++. Shortly, but first of all, we'll go over the sort of the structure of the class. So we're going to take a lot of C++ development, right? So basic language features. Essentially, we're going to look at C++ from an object-oriented perspective, right? That's basically what it is. C++ is C with objects, essentially. So in addition to all of these, all the low-level stuff that's you've probably already seen in C, we're going to be looking at classes, constructors, destructors, memory management in C++, all of those things. We're also going to look at so this is, you're learning C++, but you're also learning software design. So we're going to look at UML diagrams. We're going to look at things like encapsulation, inheritance, design patterns. Some of this is a repeat from 1406, but you're going to see how it is applied in C++. C++ is probably one of the most complex languages out there. Very, very powerful. You can do a lot with it, but yeah, there is, the specification is huge, as we'll see. So yeah, we'll look at, it's C++, we learn, but also some software engineering, the fundamentals of both of those things. Okay, so there will be, so of course you guys have your Zoom link, there will be a Discord link coming up shortly. There's no textbook required, but there's several good C++ reference books. The Deedle and Deedle C++ how to program. Also, there's of course numerous tutorials on the internet, which is, I mean, it's a pretty good resource, and it keeps getting better and better. So yeah, there's plenty of resources, so you don't have to buy any textbook. So performance assessment. So there's 9 tutorials, 4 assignments. This will I'll probably add another tutorial, but I'll still take the top 8. So I'll add a bonus tutorial most likely. So the tutorials, the assignments, a midterm, and a final exam. So what you might notice is that the midterm and final exam is worth 40, whereas the tutorials and the assignments are worth 60%. All right, and that's on purpose. This is a programming course. I want you to be programming. If you can ace the exam, I mean, that's sort of important because there is some theory stuff, but it's not as important to me as you being able to write a program. All right, so the emphasis in this course is writing programs. In particular, your tutorials, right? These are weekly assignments. I kind of want you guys programming weekly. I want you doing it regularly, not just leaving everything to the last minute, which is one way to just, have a disastrous mark. But I want you guys to get in the habit of programming, just do little bits here and there, and then you'll be surprised how much it adds up. So I made this a double pass course. And if you do the assignments and the tutorials, the midterm and the final exam should be sort of on the easy side, right? Basically, with the midterm and final exam, I'm checking to make sure that you have done your own assignments. If you've done your own assignments and you've practiced with C++, you've written these things, then what I ask you to do on the midterm and final, you should recognize all of the things, right? So, yeah, so I didn't want to, what happened last semester was that some people sort of brought their mark up with the midterm and final. I wanted to kind of avoid that. I want you to pass the programming part of the course, and then also, of course, the midterm and final, because this is just a way to check to make sure that you've done your own work all semester, basically. All right. Okay, so then we use this marking scheme, and if I didn't make any mistakes, it should be, this should give you the double pass requirement. Okay. Midterm will be held during the class that is scheduled for be open book. So this is wrong here. So I changed it to, we'll discuss this in a bit though, but this is going to be, you'll have 5 days where you can choose when you want to write your midterm. I don't like doing it like that, but because we have 3 sections, it's probably for the best this way. Tutorials are mandatory. You'll use Brightspace to submit them. The top 8 out of 9 or 10 tutorial marks will determine your tutorial grade. This includes tutorials missed because of illness. And so, I'm not going to make any other exceptions other than I'm going to drop 2 of them, your 2 lowest ones. So if you miss 2, you'll still be fine. Assignments are mandatory and you will use Brightspace to submit them. I don't drop any of the assignments. Like I said, this is a programming course. So you should be, once you get your assignments, you should be working on them weekly. And in fact, most of the tutorials are just parts of the assignments where I give you some of the classes from the assignment, you write them, you run a little Python script that marks it for you. Actually, it'll tell you your mark when I get, once you submit them and I download them, then I run the same script and that's the mark that you get. So in some sense, the tutorials, a lot of the tutorials are just basically unit tests in some sense. So we're going to take part of the assignment. I'm going to ask you to do it by itself and then run little test scripts on it, and that will be your mark. So yeah. So assignments are mandatory and you'll use Brightspace to submit them. We don't drop the lowest. You have to do them all. What I do sometimes, because I know that, life happens. Sometimes these things, something out of your control happens. So I usually reduce, it's not listed here, but I lower the weight of your lowest assignment. Oh, yeah, no, I do want to share my screen. Thank you very much. Sorry, I'm out of practice. My goodness. There we go. Yeah, like I said, I tried to shut off my brain, during the holidays a little bit to give myself a break, and then when I went to turn it back on, it was not that easy. Okay, so yes, I should be sorry. Hopefully, maybe you were following along here. So yeah, this is the breakdown of the course marks. So yeah, and as I mentioned, 60% programming, 40% tests. All right, and you have to pass both to pass the course. Okay. All right. So yeah, you'll never be granted an exemption from an assignment. So once you get your assignment started early, work on it continuously. If you run into problems, submit what you have, right? Make sure it runs, but submit what you have. You'll get some marks, and then at the end, your lowest assignment will reduce the weight of it. We won't drop it because I want you to do them all, but I usually reduce the weight of it for, anyway. It is your responsibility to ensure that your quiz and assignment marks posted to Brightspace are correct within 2 weeks of the date the marks were released. All right. Otherwise, everybody comes, of course, at the end of the semester. They take a look at their mark. They don't like what they're seeing, and they try and argue everything. So please check your marks. If you have some issues, and it does happen, first go to your TA that marked it, and then if you don't feel satisfied with that decision, then you can email me about it. After 2 weeks, all marks are considered final and will not be changed. Okay, so this is, yeah. I think we're going to go with the live via Zoom. There seems to be enough interest. And like I said, I prefer it, even though it's slightly more work, but I don't know, it's very rewarding, and it's a better experience, I think. Tutorials are submitted to Brightspace. Like I said, I give you a marking script that you can run. It's the same marking script that I will be running, although the marking script gives some input and expects some output. I might change the input and output just so that nobody hard codes answers. Anyway, we'll look at those details when they come out. All assignments are programmed using C++ and uploaded to Brightspace. The midterm is an online activity on Brightspace. As I said, it's not done during class time. It'll be done whenever you choose during the week. Office hours and all questions will be answered on Discord. Tutorials, that should read tutorials as well. Final exam is a 2-hour activity. The midterm is partially multiple choice and partially programming. Some very simple program. All right. Basically, like I said, it's meant to check to see that you've done all your own work. And if you've done all your own work, then you will find it very, very easy. If you haven't done your work, then you might find it confusing, or, sometimes the pressure gets to you and you make mistakes. Like, I get it, but that's the purpose of it, is to make sure that you're doing your own programming. And if so, it should be kind of easy. The final exam's all multiple choice, though. So far, anyway, I'll think about the final exam. Okay. Yes. So the virtual machine we're using is the same one we used for 2401. That's right. So, yeah, it's not listed here, but the requirements, it's in the first set of slides we're going to look at. But the requirements for the assignments and the tutorials is that they run in the virtual machine, and a couple minor things, like you cannot use the STL unless you're expressly permitted to, expressly told to, and no smart pointers. We're gonna manage our own memory in this class. As painful as that is, we're gonna learn how to do it. Okay, so yeah, we'll do live lectures at the listed time. So yeah, Discord, you should get an invitation soon. Yeah, and stay connected. Ask questions, talk with your peers. I know this is it's unfortunate where we are right now in terms of the pandemic, that we can't all see each other. In some sense, part of that university experience is getting together, and yeah, hopefully maybe this is the last little hurrah for the coronavirus, and then we'll be back to living our lives. But yeah, for now, you can have fun on Discord. It is a social environment, or can be. All right, collaboration. By all means, discuss how you would approach a problem. You can help each other out with, syntax and things like, oh, how do you use a double pointer again? I forget. It's okay to post things like that. I don't mind that. What you can't do is post your solution, your whole entire solution. All right. Do not do that. But make suggestions, point out problems with people's syntax, things like that. All of that is fine. Like to encourage collaboration. In the real world, there is collaboration, right? What I don't want is people copying answers and not understanding anything. The late assignment policy is detailed on each assignment. There is no late assignments accepted, although I am considering it for now, though. No late assignments. Have them in by Sunday night. We'll look at the schedule, but have them in by the deadline. And if you can't get them finished, just submit what you can. Late tutorials are never accepted. That's the official stance. In practice, I don't mind if you submit late tutorials. Just let me know. They're quite easy to mark since it's just a script. You know, if too many people take advantage of this, though, then I will have to abide by this. So yeah, if you run into problems, you have to hand it in a little bit late. I'm perfectly fine with that. But if everybody takes advantage, we'll have to get a lot more strict about it. Okay, and yeah, make sure that your files you submit have the precise file structure, especially if I'm marking by script. The script has to be able to read it. The script has to be able to find it after it unzips your file. So those things are very important. Yeah, so if you happen to miss the midterm from sickness, you can fill out a self-declaration form. But yeah, this is, you can't be exempted from any more than 2 of the tutorials, which you already get for free. So you don't have to send me a self-declaration for the tutorials. Can we submit tar files or just zip files? I prefer zip files, simply because, I mean, yeah, if everybody submits the same thing, then it's much easier to mark. That's all. So I have one script running through, it tries to unzip. I could add tar files to that, but then for now, zip files. I'll work on updating the scripts a little bit, but for now, zip files, please. Yes. Oh, yes. Email me. I'll attempt to answer your email within 3 business days. If not, there's certain times right before an assignment is due, I get tons of emails. Some of them, I just slip through the cracks and I miss because I read it when I was half asleep, So yeah, if you don't receive a reply in 3 business days, just email me again. Oh yeah, all materials are my intellectual property. After this semester, actually, I don't care what you do with them. I'm going to write all new material, but for now, don't post anything anywhere, all right? Plagiarism, the undergraduate academic advisor, who's very helpful. I'm not going to go into too much detail here, but yeah, if you need help planning out your university career, then that's an excellent place to go. The computer laboratories. I don't know what the current situation is for this. You'll have to look that up yourself if you, but generally speaking, I think all of you have a laptop requirement now, I believe. Is it this year's? I don't know. So you should all have your own laptop. And yeah, I'll end by saying there are lots of resources here, no matter what you're facing. This is, some of you are away from home or whatever, you're away from, sort of social structures that you normally rely on. So yeah, the university does its best to provide support and help for whatever you're going through. So, if any of these apply to you, please do use them, right? The university is very compassionate towards its student body. All right. So we will cover a few more details, but are there any questions on the stuff we covered here so far? Okay. Yeah. If you think of any, feel free. So we have a tentative calendar up. Basically, this week will be kind of slow. And actually, the first month is kind of slow. But don't get lulled into a false sense of security, because once we start submitting the assignments, then it's going to be pretty regular. So it just so happens we need a lot of foundational work before you can complete assignment 1. And it does take up to about this lecture. And then I'll give you another week because maybe you have questions about whatever. So yeah, assignment 1 is not due for a while, but you'll have your tutorials. And then once assignment 1 is due, then everything becomes pretty regular. Every couple of weeks, you'll have another assignment and or a midterm. So yeah, don't get lulled into a false sense of security by the fact that the beginning of the course is a little bit slow. But yeah, and again, this is a tentative calendar, so please, read your email. If there's an update, if there's a change to one of these dates, I will email you and post a new calendar. But yeah. Oh yeah, so tutorials are due Saturday night at midnight, essentially 11:59 p.m. And then basically, if you're late, submit it. Generally speaking, the soft deadline is whenever I wake up Sunday morning and get to marking them, right? So I don't know, usually 8 or 9 in the morning. The assignments are due Sunday night at 11:59. Last semester, the policy was no late assignments. I think we're going to stick with that. But the late assignment policy officially, the official late assignment policy will be outlined on your assignment. So please read that carefully once you get it. All right. And then, yeah, so we have 9 tutorials, but I think I will add 1 bonus tutorial at the end. Yeah. So questions on the calendar? Okay. Yeah. All right. I think we covered most of the stuff that we have to cover just for the introduction. So yeah, if there's no more questions, we'll start the first lecture, which is basically more introduction, but okay. So introduction to software engineering, and I added the little in C++ here. Because yeah, that is a very important component. This used to be a C++ course, and then they sort of massaged it a little bit and added some software engineering aspects to it, which is good. I think I think C++ and software engineering go well together because software engineering techniques are a good way to manage the complexity of C++. But yeah, a lot of it is just learning the details of C++. So. Okay, so it is called Introduction to Software Engineering, but as I mentioned, we have 2 main components. We have a software engineering component. So what we're going to do is introduce you to bigger and more complex applications. More complex, a lot of the complexity comes from C++, but also they're just bigger. And then we're going to look at some of the patterns and solutions and good programming techniques that we use to make these bigger, more complex programs easier to program, right? And it is also a C++ course. As I said, it used to be just C++, but now they've combined it with software engineering. So we'll look at, I already touched on this, but we'll look at a little more about why. So software engineering, we're going to talk about program design. So from a high level, we're going to look at program design, but we're going to see patterns that are often seen or used in bigger programs. Now, the patterns that we're going to look at specifically in this class are not the high level design patterns that you're going to see in 3004. We're going to stick to more low level stuff like we're going to have object-oriented programming and how do we arrange these objects in the most efficient way. So we want to have a strong foundation of how to structure your programs before we get to the higher level design patterns. All right, so we're going to talk about object-oriented programming. Most of it will be object-oriented programming, but we'll also look at some useful design patterns and the trade-offs involved. Just an introduction to design patterns, basically. So what what design patterns are used for is, well, we could actually have any problem. For any problem, we can write a very efficient solution, right? So it'll run really quick and it'll have, whatever other aspects we want. But sometimes when we do that, if we write just for a single solution, we end up with brittle code. What that means is that, okay, now my problem has changed slightly, and now I have to adapt my code. If I didn't design my code properly, then it's going to break in a lot of places, and I'm going to have to go through and change a lot of different lines of code instead of localizing my change just to one place, right? So the truth about programming is all code changes and adapts, like evolution, right? In your smartphone, you have, you constantly have your apps updating, right? Anything that stops updating eventually becomes obsolete. Okay, so software engineering, simply writing working code is not enough, right? Our code has to work with other code. It has to, perhaps present a public interface, right? So maybe we want an API. If we're writing a platform, say we're writing Facebook, then we want people to be able to write apps on our platform. So we're going to write a publicly facing API, and then there's a lot of, considerations that go into that. So the needs and, and along with it, all of the programs that service those needs are continually changing and adapting. So software engineering is about readability, extensibility, maintainability. Those things are important, right? All software will be modified, and not always by the person who wrote it, sometimes by somebody else. So readable, understandable, those are important. Extensible means that we can, add features. And maintainable, of course, fix bugs, etc. All right, and then once we stop modifying, sooner or later, it's just going to stop working on everything because everything gets updated. So as our programs get bigger, these things factor in more, right? So readability, extensibility, and maintainability, they become more difficult, but also more important, right? So we want, as our program grows larger, we don't want it to become harder to maintain. We want to sort of try and limit how difficult that gets. So certain established design patterns and practices help with this. So, of course, one of the lowest level, but very effective ways to, future-proof your software is documentation. I don't know if you've ever tried to work with software that doesn't have proper documentation, but it's a real pain. It's a trial and error, basically. Modularity. We want small pieces of code that have a clear purpose and well-defined interfaces, right? We want to write lots of little subsystems and then kind of plug them in together. That's the ideal. Now, it doesn't always work that way, but if we can do that, then we save ourselves a lot of trouble in the long run. And some of these design patterns and practices are found in the languages, right? So the languages offer sort of these high-level approaches to these problems. So we can just say, we can express what we want done instead of how we want it done, right? All right, so it's important to note that design patterns and language features that help with this stuff are not solutions. We still have to write solutions. Currently, there is no algorithm for writing an application. If there was, then we could write a program to write another program, and maybe we're in trouble at that point. I don't know. But so far that's not a problem. So, all right. So software engineering is specifically and deliberately done with C++ in this course. Why? Well, first, let's take a look at C++ and see what makes it different and what makes it the same as other languages. All right, so here we have, in some sense, a metaphor for these programming languages. So Python and Java are meant to be, very safe to use, right? With Python and Java, Java manages its own memory. Python is just a script, basically, it'll crash, but it won't take down your whole system with it. So yeah, Python, Java, basically all the sharp edges are taken away. You can't do too much damage. Your program might crash, but usually it does so fairly elegantly. C is a bit of a sharper tool, right? You can do some damage. You can write and read from memory that you're not supposed to in C. You can cut yourself in some sense, but it's very simple, right? C is not a complicated language. It's basically one step above assembly, but it gives you a lot of freedom. C++ is like C, but then we add a bunch of other tools on top of it, right? So we have the convenience of, I guess, scissors and a bottle opener and whatever else that saw thing is. It gives you a lot of tools to work with. It's still very, very sharp. We still have the original blade of C. We can still, that blade is, although it's, we can do bad things with it, we can also do very, very effective things with it. So it's it's not a bad thing. All right, so Python, Java, etc. Python and Java, they made trade-offs essentially. So, they recognize some of the problems with C. C takes a lot of skill to use properly, basically, without screwing things up, without creating memory leaks and things like that. Python and Java, sort of the philosophy is that, well, we don't want to have to deal with all that low-level stuff all of the time. So they want a higher level language where some of these problems are handled for us. And then we could they're more expressive, right? So what happens in Python, especially in Python, is I just say what I want done. And I don't really worry about how it's done, right? I can take a list and say, find whatever. I can say sort. I can open a file and read and write to a comma separated value file very easily. Python's very, very expressive. I can write quicksort in one line in Python. Now, it's not going to be the most efficient quicksort, but one line, that's pretty good. Lots of high-level features like objects and generics. Lots of language enforced safety features, right? Automatic memory management. Strong typing in Java. So yeah, actually C and C++ have strong typing as well. But so Python and Java are less efficient. Of course, Java runs on a virtual machine, which every time you add a layer of abstraction, things get less efficient. Yeah, we have less control over how things are done at a low level, especially, well, in Python, of course, because Python has a bunch of C libraries underneath it, but we don't know exactly which ones are called. But Java as well, it makes a call to the virtual machine, and the virtual machine figures out how to effectively, make what you want to have happen. So we don't have as much control over how things are done. We don't know, for instance, when memory is released, which is very important if we want to run fast programs, right? Releasing memory impacts performance. It's one of the allocating and releasing memory really slows down your program. So you want to, when you do it, is very important if you want things to be efficient. Right. So basically every layer of architecture that adds safety and expressiveness sacrifices efficiency. That's just the way it goes. So that's Python and Java, high-level languages. C is the opposite, right? It's one step above assembly language. We don't have assembly here anymore, I don't think. I don't know if you guys are familiar with it. We'll see an example of it later in the course, but it's basically machine code instructions. Not quite, but pretty close. So yeah, it's one small abstraction layer above assembly language. So C, you can do almost anything, right? So, and this freedom allows for clever tricks and hacks. this is why we do it for operating systems and things like that, because we can make this code really, really fast. We can do complicated things, but we can do them very quickly and efficiently. You know, it takes a lot of extra work to write the C code, but in the end, it's worth it. And it's good for operating systems, devices, things like that. Very few high-level constructs, right? You get what? Structs, and that's about it. Functions, I guess, too. It's not expressive. You cannot just say what you want done. You have to tell the computer exactly how to do it. If I say find, you know, I can't, there's no such thing as find something in an array, for instance, in C. I have to write that find function. C++ is, in some sense, the best of both worlds, right? So we can use many C language features. We have a lot of low-level control like we do in C. So we can, if we want, we can micromanage how my program does something, right? We can manage all those little details. I can write directly to, well, yeah, I can manage memory at a very low level. It also has high-level constructs like objects and templates, right? So yeah, in some sense, we get the best of both worlds. The cost is that we have to manage the trade-offs, and the price of that is complexity, right? So the new Java specification is 844 pages. The new C++ specification is 2,000 plus pages. It's very complicated, but it's very good at what it does, right? If you want to write a AAA game, you're going to write it in C++ because it's fast. So C++ is it's just a lot of fun. I don't know. I like this course. I like C++ because it's sort of the wild, wild west. They say, here's the rules and constructs for writing good software. But, you know, if you want to break all those rules, go ahead. You know, that's sort of the ethos behind C++ is that you should be able to do whatever you want. So yeah, that means, yeah, the philosophy is you can have as much control. The price is, of course, it's complicated. So we're going to hopefully learn how to manage that complexity in this class. So the dangers of C++, memory leaks, segmentation faults, and many more. If you've done C, which most of you have, last semester, I assume, you're familiar with these things, but you're going to see them more here again. So why do we use it? Things like AAA games, you know, anything where we need to have efficient code, but also high-level abstractions. So if we cannot sacrifice efficiency for safety or expressiveness, then C++ is a good choice. You know, we want something, we could want to be able to express things at a high level, but we also want it to be efficient. Then we want C++. All right, so now why C++ and software engineering together? Well, the complexity of C++ can be managed by using good software engineering techniques, right? So yeah, this makes them a good fit because C++, like anything that's sort of a little bit powerful and dangerous to use, can be managed by using good technique, right? So we can mitigate the risks by knowing how to use them well. use C++ well. Okay, we will get to some programming. I know I'm talking a lot. Any questions before we, am I boring you guys yet? All right. Okay, so software engineering, yeah, is basically about trade-offs. If I do X, then my software runs slower, but it's easier to modify. If I do Y, then my software runs quickly, but it's more difficult to modify without introducing bugs. Which of these is correct? Neither really. It depends on what you need, right? But software engineering is about knowing how to manage these trade-offs. All right. So yeah, depending on where you work, your company might have a different philosophy, might desire a different outcome. So the correct software engineering technique is in some sense the one your boss tells you to use. we have sort of in this class, we have, I guess, a list of practices that we want you to use. And I'm not saying that they're absolutely right. They're not absolutely right. They're right for this class. Okay, so in some sense, you could think of it as, I don't want to be your boss. I'm your teacher, but when I give you a specification, I'm expecting you to sort of follow the guidelines of that specification, right? I want you to use the techniques that we're showing you. That doesn't make them right, but these are a lot of these are techniques that you haven't seen before, and I want you to understand the trade-offs, right? So I want you to be able to use them. But yeah, when you get out into the real world, do what your boss tells you. There's no right or wrong. There's just right for the environment. It's important that the team are all on the same page. So yeah. All right. 16, man, how many? Let's go on and on here, eh? All right, I'm going to skip some of this stuff. We'll talk. You can read this at your leisure, but I would like to get to some programming today. Yeah, software engineering basically came about because of pressures, right? So the need to change software again and again meant that, if you have to change your software, you go back, you make the changes, you realize how difficult and a pain it was. And then you have to change it again, and it's also a pain, but hey, you realize, if I use this little bit of abstraction, this layer of abstraction, it becomes much easier to change. And that's basically how these software engineering techniques and design patterns came about, because it made programmers' lives easier. So one of the goals of this class is that we're giving you bigger programs, more complex programs. We want you to feel the pressure of writing these programs and see how software engineering techniques can help make things easier. All right. Yeah, and we're setting the foundation for COMP2404. So COMP3000, here we ask you to do assignments. We hold your hand through it a little bit. We give you, very sort of fine-grained instructions so that you can see the techniques, you can see how they work and perhaps get used to them. So you're not really a free-range programmer in this class, right? That's in 3004. In 3004, they say, they give you a specification. They say, I want a program that does this, right? I want a system that does X, Y, Z. You figure out how to do it, right? So you're free range in 3004. Here, you're not quite there. We're still going to be holding your hands, walking through C++, and learning about it. So learning outcomes, we want you to have a good foundation of C++, right? When you go to use more advanced C++ libraries like Spark pointers and things, you should have no problem adopting them. Basically, that's our goal. We want you to understand the low level. We want you to use make files to compile. We understand what a make file does. When you write C++ code, you have to start thinking like a compiler in a lot of ways. And we'll talk about what that means. And we're going to manage our own memory. We're going to do all the things that make it a pain. And then once you learn that, you can do anything you want with it. I don't recommend using a complex integrated development environment. You will just end up learning the IDE instead of C++. All right. I think when you're learning a new language, it's important to start from the command line. Text editors, command line commands, basically, so that you understand what's happening at a very low level. And then if you want to go use a fancy IDE, you can. You will understand how to troubleshoot it better, right? So knowing the command line lets you troubleshoot an IDE, but knowing an IDE does not let you troubleshoot another IDE or the command line or things like that. So we're going to start with plain text editors, gedit, which I don't find works very good in the virtual machine. I think I was looking at them. I think I'll start with Atom, which is just a simple editor as well, but it has code highlighting and stuff. But you can use Notepad, Notepad++ if you're in Windows, whatever Mac has, I'm not sure. And yeah, we're going to compile and troubleshoot from the command line. Later, we'll move to a smarter editor, not an IDE. I still want you to, or at least what I'm going to do is use Visual Studio Code because it highlights compiler errors before you compile, which is a really nice feature. It saves you a lot of time. Instead of having to compile every time and then try to read the compiler output, which sometimes is not that useful, you'll get a little squiggly line under something that means, hey, look at that. I think, you have an error here, and then you can kind of check what that error is. That's a nice feature. It'll save you a lot of compile cycles, but I still want you compiling from the command line, knowing how to write a make file, things like that. Okay. Yeah, well, we'll get to some programming, hopefully. 1224. Okay, so learning outcomes of the software engineering, that's the learning outcomes of C++. Learning outcomes of software engineering, object-oriented design. We're going to learn a little bit of UML, not too much, but a little bit, the basics, right? Some design patterns and architectural styles. We won't really use them that much. And we'll use some of them. That's not a big part of the course. It's just, a little bit of introduction to 3004. And yeah, I'm against using design patterns because it is the right way to do things. When I first learned about design patterns, I did things like over-designed my code, right? I tried to plan ahead and say, oh, I need this abstraction layer here and this abstraction layer here. And then what happens is that I do all that. And then once I start writing the logic, well, it turns out how I implement my solution changes, and I don't need all those things I wrote. So there's a do not over design your code. As your program gets bigger, you should add more and more design patterns once they become effective enough to use, right? So this is, once you start learning design patterns, there's this temptation to put them everywhere. So I think that's counterproductive. All right, so yeah, this is a repeat of all the things we said before. We're using C++ and medium-sized programs. We're going to make your lives complex. And then hopefully some of these design patterns, you'll see how they help to alleviate the complexity. Protect you from making mistakes, understand your own code better, implement changes in your own code more easily, find mistakes. If you want to see how well or how poorly your code is designed, write an application, right? Put it away for 3 months and then come back in 3 months and try and add a feature to it. And your eyes will be open to not only all the things you should have documented that you didn't, but also, what design patterns you could have used that could help you add features to it in the future. Okay, the VM is a Linux operating system, right? It's what is it? Ubuntu, the Xubuntu, which is based on Unix operating systems, which were developed in Bell Labs a long time ago in computer science. For a long time ago in computer science is not that long ago, but it's Unix compliant. Mac OS is also Unix compliant. So there's certain things Are you guys still there? Sorry, I saw my Wi-Fi drop off. Okay. All right. Sorry, yeah, my Wi-Fi just, there was a question mark there, and it wouldn't be the first time that I lectured to no one. But yeah. So Mac OS is Unix compliant. I don't know much about Macs, and I'm sorry, but so there's a lot, the Unix command lines you can use on the Mac OS, but as far as what C++ compilers it has, I don't know. You'll have to look that up if you have a Mac. So yeah, Linus Torvalds developed Linux as a hobby. It's roughly Unix compliant. It's modular, it can be easily extended. It's open source. So this is a free, and which is kind of nice. You don't get all these annoying ads and people always trying to monetize something. You can modify any part of your kernel, any part of your operating system, which is nice. You can modify programs, which I've done actually. It's not as difficult as you would think. So that also has dangers, but it's designed for simplicity rather than being user-friendly. But yeah, Ubuntu's pretty user-friendly when you get down to it. Okay, it's very developer-friendly. It's really nice. It was initially written in assembly. Then they developed C on it. And then they rewrote Unix completely in C. And Linux is also written in C. So there's a really strong relationship between Linux and C and C++. You know, they work with C and C++ out of the box. A couple of quotes. Unix is simple. It just takes a genius to understand its simplicity. Right? It is simple, but it's like. Unix was not designed to stop users from doing stupid things, as that would also stop them from doing clever things, right? And that is very applicable to C and C++. They give you any tool you want. If you ask, can I do this in C++? The answer is probably yes. They'll let you do it, but whether or not you should do it, I guess, is up to you to decide. All right, so it's part of the Unix. The Linux operating system is part of the Unix family, which is, Ubuntu, Arch, Mac OS, BSD, Solaris. Android, your Android phone runs on a Linux kernel. What else does? There was something else I was just looking at the other day. Well, if you have a VR, that runs on the Linux kernel. If you have an Oculus VR, that is. But yeah. Linux on the web. So depends on where you look, but and how the statistics are gathered, but Linux servers are very, very popular. They're very, very robust, and some of them have been running for years and years. So Linux distributions represented 6 of the top 10 servers, FreeBSD 3 of the top 10, and Microsoft 1 of the top 10. So yeah, it's very popular on the web. And it's been hacked by a lot of people, and then the best features are kept. Okay, so what is a shell? We'll be using a shell to run our programs. A shell is an interface to the operating system. It's a command line, right? Very similar to the Windows command line. If you've used that, I don't know what you guys are familiar with, but basically we can run commands on the operating system, look through the file systems, execute programs, etc. Some of the more common shells you'll see, the Bourne shell, the Bourne again shell. So this is the default shell for Linux. So this is the one you use most often. Some people have preferences. I know Christine has preferences because she's used it a lot more than I have. To me, there's very little difference between all of them. But if you're really into shells and into what they have to offer, there are some differences. But generally speaking, most of the commands are the same. But yeah, very little. Unless you're into it, then if you love shells, then of course you'll have your favorite. Some of the shell commands. So these, we're going to experiment with these a little bit. So ls lists the files in the current directory. cd changes directory. I think this is the same on Windows. chmod plus x file will make that file executable. So you will have to use this command when you do your tutorials in order to make the marking script run. So you'll import the marking script, and then you'll have to make it executable on your system. So you'll have to give it permission to run. Yeah. So if I want to execute a file, I write ./file. And this will look in the dot means the current directory. And then this is a file in the current directory. If I just write file, like if I just write a command, let's say I wanted to run my program P1. If I know it's in the current directory, I can write it like this. If I just write P1, it looks at the path variable and it looks at wherever that points to. It'll look, basically the path variable points to directories that have all of the commands for your operating system in it. So yeah, when we run programs, we're going to use the // I guess / maybe. And cat, this is, I think it stands for concatenate, but that will list the contents of a file to the console. grep is very useful and powerful. Search a file for a string or, a directory. And there's a bunch of other ones. Okay, so our programming tools that we're using, text editors, and we're going to use them to write programs and make files. Okay, so we're almost there. The compiler we're going to be using is the GNU C++ compiler G++. The default standard is C++ 98. Mandatory in this course. I don't want anybody to get hung up on whether or not you're using actual C++ 98. Basically, if it runs in the VM, it's probably fine. Don't use don't use any of the libraries you're not supposed to use. Don't use smart pointers. But I'm not really going to get hung up on whether or not it's C++ 98 compliant. Just make sure it runs in the VM. Some of the options that we use when we compile, -O specifies an output file, -C compile an object file. We'll talk about object files a little bit more in a minute. When we compile code, it must be compiled in the same environment we execute it in. So if we compile it in Windows, it's not going to run on Linux. It's not going to run on a Mac. It's going to look for certain Windows libraries and things like that. All right. So let's start. Let's look at a programming example. I'm going to start by. So VirtualBox is probably the virtualizer that you want to use, but perhaps you might use Parallels. It depends. If you have a Mac that uses what's that new it's got the new chip in it, right? Which is the M1 chip. Yes, you'll have access to OpenStack, and Andrew is he's going to make some instances specific for this class. So yeah, there's a couple things. Yeah, you can use OpenStack, which is basically from the command line, you can basically log into another computer that runs in Carleton somewhere, and then you can run C++ on that. Now, it's just a virtual machine basically running on a server at Carleton. There are links on Brightspace for how to do that, or at least there should be. If not, I'll get them up there. You can use VirtualBox. You can use, I think, M1, maybe you can use VirtualBox now. If not, I think some people had success using Parallels. Is it Parallels? But yeah, the M1, there was some trouble with it last semester. So once you guys get on Discord, maybe you can talk about it, see who's found a solution, and maybe they've updated the VirtualBox in order to use M1 now. I'm not sure. Okay, VirtualBox won't work with M1 even with Parallels. Is that right, eh? So yeah, you might be stuck with OpenStack. The other thing you can do is just get an old computer and install Ubuntu 20.04 on it. Yeah, VirtualBox is only meant for x86, but I know some people got, I don't know, there's been, anyway, I've heard different stories, so I don't know which is accurate, or maybe it depends on, I don't know. OpenStack works great. Yeah, I mean, you're working from the command line. You can't even tell that you're on another computer. So, all right. Okay, so here is Oracle. I'm going to import an appliance. I'm going to look through my local file system. And yeah, so I find the appliance, which is the COMP2404 fall21.ova. I click next. The default settings are fine, and then import. So this is really made to be very, very simple. Plug and play, essentially. You don't have to mess with any of the settings or anything like that. If you use OpenStack, it's a little more complex to get set up, but once you get it running, you should be fine. I got it working last semester. No, you can use the same virtual appliance. Yep, this is yes, if you've done 2401 last semester, then this is probably a review for you. So you can use the same one, no problem. All right. And it's nice and lightweight, so it's relatively fast. It doesn't take up a lot of your resources. So the password is student. And then we're in. Okay, so from here, there's a couple things you can do. I like using a shared folder. The nice thing about a shared folder is that if your virtual machine crashes, if it runs out of memory, I still have access to my files. I don't lose them. So I'm going to add a shared folder. Yeah, and I want to add this one. So this is all the class code. So I'm going to open that. I'm going to put auto mount, and I'm going to make it permanent so that the next time I open this, it will still be there. You don't have to do this. You don't have to use a shared folder. You can just write your code in your virtual machine. I like doing it this way, but it's not really right or wrong. It's just my preference, I guess. Okay. So now in my shared folder, I have this shared folder _ code, and this is all of the files on my host operating system. So now I can do things like, for instance, I can install Visual Studio Code on my host operating system, and I can write the programs in Visual Studio Code, and then I can run them over here in my virtual machine. You can install Visual Studio Code on your virtual machine, but beware, you will probably run out of memory at some point. So that was sort of the recommended way to do it last semester, but as it turns out, this virtual machine does not have a lot of extra memory. So I would stick to not installing those things on it, and just, if you write your code, that's just text files, it should be fine. Do we need to re-import this? If we, no, it's okay, sorry. It's the same question as before. So, all right. Yeah, don't install Visual Studio Code unless you're comfortable. You can also hack it so that the memory is larger, and then you can do whatever you like. But that's sort of, I'll leave that up to you if you want to do it. Okay, let's write some programs. All right, so here I have p1.cc. I'm going to open it with, I like Atom. Okay, so this is, let's close some of these welcome things. And let's make it a little bit bigger. So here I have a program called p1.cc, but let's start from scratch. So the entry place to any, I have a file here called p1.cc. So that's what we're going to label it. So we're going to be header files and source files. Source files you should label .cc. So this file is p1.cc. You guys see that? And now the entryway to any C++ program is the main method. So the main method has a return value of an int. It's called main, and then an open brace and closed brace. Now the return value of an int, so I'm going to write return 0 means return without an error. And then I can put my code in here. So what we want to do is we're going to write the hello world, the C++ hello world. All right, so what we want to do is, we're going to write something to the console. So to do that, we're going to need an input-output library, right? So to include a library, we write hashtag include, and then the less than sign, IOStream, and greater than. All right, so IOStream is the library. This is sort of like an import call in Java or Python, but here it's called include with the little hashtag, and IOStream is the name of the library that gives us the ability to read and write from the console. Okay, so now inside my main method, I have this, and I can write cout. Now, this is the, we'll get into namespaces and stuff in a minute. I am deliberately making a mistake here for those of you who are concerned at this point. But cout is how we write things out to the screen, and this is called the stream insertion operator, right? So the less than, and then I can supply a string, for instance, and say, hello, COMP2404. Okay, so I could end it there, but of course, normally I want to put a new line. You can use the, this is the C new line. I don't want you using that. It's not a bad thing. I want you using this endl. So I put another stream insertion operator and the endl command, which means end line. And this puts a new line at the end, and it also flushes the buffer. All right, so that's the big difference between this and this, is that the end line also flushes the buffer, which is useful when you're debugging your code, right? So it could be that I write some output to the screen, but then my code crashes afterwards. The buffer is not flushed. So now I think the crash occurred somewhere above that, right? So this will be extra helpful as we're learning C++, so that to make sure everything is printed out to the screen when it should be and not stuck in a buffer somewhere. Okay. All right. So now I'm going to open a terminal here. And then I'm going to write G++. I get that bigger. Okay, so G++ and then p1.cc is my file. All right, so now it tells me there's an error. So what happens is these are in the standard namespace. So in order to properly use them, I have to write the namespace in there. So this is a bit of a pain, but it works. So now if I try and compile this, it compiles. So now let's list this directory. I have a.out, I have p1, that's an old one, let's remove that. And I have p1.cc. So a.out is by default the program name that it makes. If I don't supply a program name, like I did not supply a program name here, it says a.out. So I can run a.out, right? So again, ./ means look in the current directory and then run this program a.out. And it says, hello, COMP2404. Okay. Questions so far? I don't think any of this is too mind-bending. Okay, so this P1 is P1 the object file. P1 is an executable. Yeah, we're going to talk about object files, maybe not today, but definitely next class. P1 is an executable. Object files have a .o. So they're .o files. We'll get to what they are and how we use them. Like I said, probably next class, early next class. All right. So this standard ... this is called the namespace. These are in what's called the standard namespace. But instead of writing the std ... every time I want to use one of these commands, I can just say using namespace standard. Okay, so now it says, well, now the compiler will recognize these commands because it says, well, okay, I can just look for anything that's in the standard namespace, which includes the cout and the end line commands. Right, so let's save that, just run it. So again, I can, yeah, let's just do, for now, let's do this. That seems to work, a.out. Okay, so I've said using standard namespace, which means I don't have to put the std ... in front of all of these anymore. So whenever you write a program, probably almost certainly these will be the first two lines, right? Or they will be there somewhere, because that we most often want to read and write from the console. And since those commands are in the standard namespace to make our life easier, we're going to say that we're using the standard namespace. Okay. The other thing is this a.out is not the most convenient name of a file. So I have this p1cc.cc. I want to compile it to an output file. So I'm going to use -o. I will call it p1, and the file that I want compiled is p1.cc. All right, so everything worked well. I now have a file here, p1. It's an executable. Hello, COMP2404. All right. And yeah, somebody mentioned object files. The difference between an object file is still compiled instructions, but an object file is generally incomplete. There's not enough there to run a program. And we'll see the different ways that we can do that. But yeah, any questions? Okay. 3 minutes. Maybe we can do object files. Okay. Depends on if I have. No, I don't have anything. Okay. Yeah, well, we can very quickly make an object file out of it. Let me see if this works. So if I say -c instead of -o, I can take this. It has a main method in it, which is kind of unusual for an object file, but I believe it'll still work. Right, so I say -c p1.cc, that makes my object file. Now, when I list them, I have p1.o. Now, I said typically the difference between an object file and a executable is that an object file is incomplete. This is actually complete, right? It has all the commands I need to run it. The problem is I I don't think it'll run. Yeah. So it's not an executable file. So there's some, little tweak to the file structure that hasn't been made. This is essentially just a library of code that I can use. One thing I can do though is I can take that object file and what's called link it to an executable. So I'll put -o, P1 is my executable. Actually, let's remove P1 first. C++ -o, P1 is my executable, and now I want to link the object file P1.o. And yeah, so that's going to take the code that's in here, take the code that's in, it's not letting me do that. All right, that's fine. It's going to take the code that's in this file, and it's going to put it in this file, but it's going to do whatever tweaks it needs to do at a binary level to make it run. Okay, so now I have a P1 executable that still runs. So now, why did we do this? It seems like a waste of time. I'll show you why next class. It's because when we build programs, we want to build it piece by piece and then sort of glue it together at the end. And that helps so that if I make changes to one part, I don't have to make changes to all of the other parts. So that's the purpose of these object files. Is namespace just a library? It's a way of resolving name clashes, right? So really, it's not a library. It can be a class. It can be a library. We're going to get into namespaces, but basically I can make anything into a namespace. I can put anything in a namespace. And generally I want to do it if I think, well, there might be some other function named cout, then I want to make sure I don't have a naming conflict, right? So I'm going to put it in its own namespace. And then when I call it, I can specify the namespace so that the compiler knows which function to call. All right. Next class is Wednesday, and I think I'll go live. I don't know. If people keep showing up, I'll keep doing live lectures. So yeah, that's it for today. Yeah, I can stick around for a few minutes to answer any questions you have, but otherwise I will see you guys on Wednesday.